will be the topic that Avi will be talking about today is changing the narrative of our industry from rapid prototyping to additive manufacturing to design, agility, and digital supply chains. So without further ado, I will hand it over to you, Avi.
It's great to be here, Victoria, and welcome everybody. And I would add to that nice introduction, still a disappointment to my mother. So I'm still trying hard. I want to talk a little bit about reinventing the narrative and what's happening in the industry, at least from my perspective of a longer time practitioner. And I want to start with the pace and rate of change, which continues to, I think, amaze, and the level of talent that is being attracted, but also the dollars that continue, or euros that continue to come into the field. So I'm closing in now on 17 years in the industry, and I have to tell you that more has happened in the last 2 years than in the previous decade. There are many more players today, surprisingly, that are actually innovating and pushing the envelope well beyond what we have seen in more than a decade and a half. And that many of the younger unicorns are actually valued higher than some of the publicly traded incumbents, which creates a very interesting tale of two cities, which I'll speak to for a couple of minutes. And most interestingly, amidst COVID-19, which is one of the most horrific events and pandemics that has happened certainly in my lifetime, we're seeing additive manufacturing, 3D printing really come through and address both the speed and agility of design and the immediate remediation of supply chain weaknesses, or quite frankly, just a broken supply chain. And what that means is that there is an opportunity here to use this horrific event as the ultimate catalyst that mainstreams 3D printing. You can see what's happening to the more established companies, notwithstanding their great presence and access to market and incredible technologies, both on the thermoplastics, the thermosets, the metals, and derivatives thereof, and notwithstanding the impressive revenue and deployment and global presence, they have not been favored by the public markets, certainly not in the last 4 or 5 years, whereas some of the relative newcomers that have gotten traction and have been mentioned in the prior conversations, like desktop metal and carbon, have certainly now enjoyed greater valuations with less revenue, and have been able to attract the level of funding that allows this kind of progress. And another interesting transformative force within 3D printing is that we are seeing the average selling prices of industrial 3D printers, not the desktop variety, really following the kind of dematerialization and demonetization curve that many other exponential industries have followed, like storage and computing costs, and even robotics, which is typically a precursor in combination with innovation for the next breakthrough. So there is a great deal that still needs to be done to mainstream 3D printing, and I think that we have a real opportunity coming out of COVID-19 to actually focus on it. And what a good friend of mine, has been saying for quite a few years is that the world's biggest problems are the world's biggest opportunities, and this is how I'm viewing this combination of COVID and additive. A little bit about myself and what I'm passionate about. I'm passionate about harvesting the upside of disruption for the benefit of humanity. I think that ultimately we have a responsibility to give back and to pay it forward. And I've been fortunate to be on this journey for a long time, and I'm willing to risk and live with this measure of uncertainty and risk, and commit assets and resources to really make a difference and make an impact. And for the last 5 years, I kind of put my effort and my money where my mouth is, and started about 8 companies, most of them in generative and additive technologies. The one that I really want to talk a little bit more about today is Nexus 3D, which I view as a real moonshot in the sense of taking 3D printing speeds from, call it, a paradigm of dial-up internet to broadband, and getting as close as we can to real-time printing, because I think that is at the heart of not only material properties, or where surface, finish, and properties can converge, but it's also about size, it's about scale, it's about repeatability. And that is something that gets me excited when I get up in the morning. And I view it as a moonshot because to really mainstream additive manufacturing within all of its constraints, and we've heard a really great overview from Greg just now about some of the key thermoplastic and thermoset technologies. There is a real question of speed, because it speaks to productivity, capacity, and volume. There is a real size constraints. We've heard that inherent in some of the existing DLP systems is the relatively small size. Material diversity, and really the ability to unlock mechanical properties as you grow parts, is still in its early stages. And ultimately, to be able to make your first print, the production print, there is a need for greater quality, repeatability, as all of that is being scaled. So the journey that we have been taking with Nexus 3D, now going on 5 years, is to try and figure out how do you really scale speed, size, material science as you grow the part, surface finish, quality, in a way that really put parts in our hands in a reasonable speed, and a speed, by the way, that gets tested during periods like COVID. And how does one build a truly industrial grade system that can fit on the factory floor, can run 24/7, and solve some of the fundamental physics and chemistry challenges that certainly have held our industry back for decades. So for us, what it meant is to really develop a completely different technology stack, which I'm sharing with you here openly, which kind of gives us a unique blend of physical flexure of a membrane with a proprietary material composition. Central to all of this is this membrane that also acts like a diaphragm pump and allows for the quick replenishment and the non-stick layer. And the freedom to graduate from the confining size and imaging capabilities of a traditional DLP-based technology and creating more of a versatile light engine that is based on LCD, on light guides, and on an LED array that can provide much larger sizes, edge-to-edge uniformity, and in combination with this composition of membrane also allows for a much faster speed. The result of 5 years of research and development and product development is the first system that at Nexa 3D we brought to the market over the last few months, which is the NXC 400. And for the first time, we are seeing how it's all coming together. It's about 5 times larger than your typical DLP build plate. Depending on how you measure speed, whether it's part in hand or after the post-process, it's about 6 times faster if you compare part to part in hand. If you add to it other systems, baking cycles, it can be as fast as 60 times because here we're working only with single component materials. And what is really striking is that we're pushing really, really hard here to shrink the gap between surface and feature detail in holding tolerances versus material properties. And the way that we do this is through a truly open platform that works in partnership with, I think, some of the best and brightest material suppliers, because one of the lessons learned, if you will, from prior experiences is that no one company can really do all of this by themselves, and to really mainstream 3D printing at scale, we need the kind of partnerships and collaborations between machine, software, process, and some new materials that can really not be an either or, not be either mechanically performing but don't look good, or look really good but have limited mechanical performance and functionality. How do we create the both and? And this is what you see as a result of the ability to tailor the heart of this system, which is the membrane, to specific materials. In fact, yesterday, we went live with our partnership with Henkel and introduced this XABS black material. You can see that it can take quite a bit of abuse and yet give you the look and feel and touch, both in terms of the tactile and haptics, but also the mechanical performance of a true ABS. And that is just a precursor to an expanding portfolio of materials, courtesy of some of the best young and more mature
Hey, Eric.
material
Hey, Joel.
company.
Last time we met, we were doctors. How's it going, Joel? Hey, Eric. Nice lab coat.
Thanks, you look very professional.
Thanks. You as well. It seems in our doctor garb. Now we've got gloves on. Why do I have a glove on?
Because we are here to show you one of the world's fastest SLA 3D printers.
And did it make this?
It did. How much time do you think that it took to print this?
Let's see. I'm going to hold this. Okay, this is a giant Einstein head, and it's pretty tall. And on that build plate, this is resin. I would imagine 15 hours, 20 hours.
2.5.
Serious?
So this is the kind of typical reaction that we get today from people that are exposed for the first time to either a live demo and see for themselves, both in terms of size, speed, surface, but also detail. I mean, if you look at the part here, this is a part that typically would have been made on an SLS machine. And it was first part ready to go at convincing speed and scale. This is even more interesting. Conventionally, we think of 3D printing, the complex, the organic, the odd shape, the prototype. I want to show you here an example of 3D printing, just ordinary gears that you would typically just injection mold. And what we have here is basically, you wouldn't guess this, but we have in total 5,000 gears that were printed in a single print here in about an hour and a half. So when you begin to think about, you know, could I seriously consider in terms of productivity, material performance, an alternative for simple parts that typically I would not think twice about tooling, think again, because you know, these kinds of paradigms are going to be challenged and changed. Now, what's interesting in all of this is that that have been thinking about this distributed manufacturing for production for a long time and have built their entire product strategy around it. And if you think that it's not going for functionality, think again, because you see that they also demonstrated successfully that it can pass all of the crash tests that are required for transportation safety and regulatory compliance. I want to show you an example of some work that we have done here at Exponential Works in Ventura with a company called Arakimoto. Arakimoto is a little publicly traded company that is bringing to market this EV tricycle. They call it a fun utility vehicle. And they have designed it and produced it in a very traditional way. And we wanted to show what design agility, what design really looks like. And for us, design agility was about using generative design to take these parts and lightweighting them. We wanted to put the vehicle on about a 200-pound diet quickly. Took us 2.5 days to using parameters, generative design, to go from parts to patterns, from patterns to a foundry for casting. And we delivered in less than a month a vehicle that by weight was reduced about pounds, which was just the beginning to show what you can do in terms of design agility, but also the simplification of supply chain. And why supply chain resiliency? Because with 3D printing, for the first time, we have an opportunity to combine parts, to localize the manufacturing, to simplify the procurement, and to understand that when you have the kind of disruptions that we have witnessed starting in January, cost per part needs to be computed very differently than it was computed in the past. The idea of design agility and supply chain resiliency is not limited just to 3D printing. I want to show you an example of what we're doing with 3D knitting, which is taking these machines that used to make sneakers and sweaters and playing with the knit patterns to create a 2.5D that can be a very effective face shield, just as an example of agility and resiliency. And even more interestingly, I want to show you the work that we're doing at Nexus 3D with test swabs. We now have the capacity to be able to manufacture about 500,000 test swabs weekly, subject to a successful completion of the IRB process with a few hospitals here in California. So the final aspect that I see coming out of COVID for additive, in addition to design agility and supply chain resiliency, is the future of work. And I think that we have learned a great deal about the power and flexibility of remote work using virtual tools, just like we're using Zoom now. I view 3D printing, and especially how we sprung into action across the world, makers and high schoolers and professional companies, the way that we have organized ourselves, I think shapes and informs the power of 3D printing and its ability to be part of the digital literacy and hyper-local deployment of teleporting parts and delivering them, literally at the speed of Zoom. And I think that's a very powerful third part of the narrative of 3D printing: design agility, supply chain resiliency, and a good friend of mine is running a great company. Its name is Goodyear, and they've been making tires since before most of us were born. Believe it or not, it's been about 5,500 years since the original wheel was invented. And most of my life, I got the advice from many people: don't go out reinventing the wheel. Well, I think that COVID-19 is changing everything, including the reinvention of the wheel, which quite a few concepts have been shared already. Fortunately for us, we don't need to reinvent the wheel, but we do very much so need to reinvent our businesses coming out of this pandemic. I think that it represents a great opportunity. I think that we're extremely well positioned. And I also think that no one company can do it all alone. So if there ever was an opportunity to create coalitions, to create collaborations, as we have seen throughout this COVID-19 pandemic, that is the only sure way to be able to harvest the upside of this disruption. So thank you.
Thank you very much, Avi, for that presentation. Very insightful. I have, my own questions, but we have had a few come in through the Q&A and chat. And if any other attendees would like to submit their questions to Avi, now is your chance. So please do go ahead. We had a question earlier in your presentation where someone has asked, if you could provide any advice to a company that would want to adopt additive manufacturing.
Absolutely. I think that the first thing that you want to do is analyze your business and kind of ask yourself, where are the low-hanging fruit for me? Where can I begin to adapt? Depending on your business, it may be first in product development and prototyping, which is a no-brainer. If you're not doing it yet, you ought to do it. The second is if you're in any kind of a manufacturing activity, look at your jigs, fixtures, and gauges, because that will be another area that is almost fail-safe. Designate a few people in your company to become the experts, and find a few external experts. Work with somebody that can be a good guide. There is no need for you to repeat the same learning that somebody else already have. So compress your learning curve, work with service providers, work with some advisors and guides, start the dialogue with some of the suppliers, form your team, select a few low-hanging fruits so that you can taste success quickly. And in the process, within a few months, because everything that we do here is agile and rapid, within a few months, you can begin to zero in on the opportunities that are specific to your business.
And from your experience working with the different companies you have, do companies tend to have those things already in place where they know they need to have maybe an expert team or a key stakeholder, that they need to know what application they're targeting? Or does it tend to be sort of, let's jump in and we're not quite sure where to start?
Well, you see it coming in all flavors. Some companies wake up and say, oh boy, we hear that everybody around us or in our space is doing it, let's jump in, and they set budgets and resources, and they try to figure it out on their own. Other companies kind of survey the capabilities that are available, try to come up with a specific project to kind of cut their teeth on, and they start. The smarter approach in this day and age is, figure out who do you want to surround yourself with, do a few experiments through a service provider, a service bureau, find a few knowledgeable people that can guide you, plug into the right communities, and then do an assessment of where and how can I plug in additive manufacturing into my business. That, in my mind, is the smarter play.
Fantastic. We've got a couple of questions specific to Nexus 3D and Nexus 3D's technology. So Pedro's asked, referring to Greg's presentation earlier, who mentioned that most resins are toxic and that it might be a challenge for this kind of technology. Is Nexus 3D addressing this in any way, and if so, how?
It's an excellent question, and what I wanted to show you here is this is what comes out of Nexus 3D. This is a material that we introduced yesterday with Henkel. The key to making sure that a material is completely safe for handling and use is to make sure that it's processed well and it's cured completely, because you don't want to put in the hands of anybody kind of work in progress. Secondly, you want to make sure that these materials can come in contact, with your hands and with others when they are in use, which means you have to be able to certify the complete process. And finally, there has to be a sustainability component in here. And it's true that today photopolymers are not necessarily recycled back to their original raw material, but they could be recycled. For example, they could be grounded and reused as fillers for things like park benches and cans. They could be recycled and blended into carpet underlays and sound insulation. So there are many ways to look at sustainability. And for Nexus 3D and for me personally, the whole notion of sustainability is of paramount importance. And by the way, it doesn't stop with just recyclability. We need to think about the energy inputs. We need to think about the kind of jobs that because there's also the personal sustainability that comes with this technology. And so for myself and for Nexus 3D, we're taking on the topic of how do we make sure that our industry is part of sustainability into a much broader application of just, is the material safe or not? Of course it must be. Is the process safe or not? Of course it has to be tested and certified. Is the material recyclable? Yes. How can we recycle it, in new and creative ways? But beyond that, what's the carbon footprint? Are we going to be part of a resilient supply chain that minimizes transportation, reduces warehousing, reduces the energy input? And how do we make this also a sustainable industry for the people that are involved in it? That's kind of how we look at sustainability.
And so when you say sustainable for the people, what do you mean exactly?
I think that we have a responsibility to, as an industry, to think about the quality and meaning of the jobs that we create. How do we think about the future of work, especially post-COVID-19, and what role does 3D printing play in the future of work? Because human sustainability, the ability to earn a living, to be productive, to make a difference, is very much, in my mind, part of sustainability. I mean, we need to make sure that we have a sustainable planet, but we also need to make sure that we have a sustainable industry that is growing and thriving, and in which we play a role in the future of work.
Great question. Thank you very much, Pedro, for sending that in. We do have, Pedro has just responded, yes, there are many ways to think about sustainability, indeed. We do have another question relating to Nexus 3D's technology. It asks, in DLP 3D printing, there is also a post-processing step, which involves curing a part. How long does it take on average with Nexus 3D's process, and do you provide curing equipment?
So it's a great question, and of course, being that this is a photopolymer process, there is a second cure step. The curing in our case typically takes between 10 and 20 minutes, depending on the part size, the complexity of the geometry. Remember that when we build parts, we can build parts for up to 19 liters in volume, so they can be quite large. And as a result of the fact that we could build those large parts, we also designed and built a much larger curing station that can take an entire large part and drop it in a mechanized way and cure it. That curing station is going to be commercially available in June. We were going to make it commercially available last month, but in the wake of COVID, we pivoted a lot of our activities towards making things like this for our community, and decided to postpone the curing station until June in favor of making thousands of these. We think that's more important right now.
Of course. I just wanted to touch on, so with the technology, one of the things it's trying to address is print speeds. And I wondered if you could just expand a little bit on how you guarantee such fast printing speeds and how that works with the proprietary technology you use.
Yeah, so the way that it works is in two ways. One, we minimized any sticking force to the bottom of a vat, because we don't have a bottom, we have a very flexible membrane. That membrane is chemically treated in a proprietary way to minimize any peel-off forces. If you don't have to worry about the peel-off forces, you can image and flush a layer much faster. If you can flush a layer much faster, the next question is, how quickly can you replenish that layer of resin so that you can flush and cure the next one? And that's where the flexure of the membrane comes in. It acts as a pump, as a diaphragm, and it speeds up the resin replenishment, which becomes more acute and more critical with higher viscosity materials. If you can successfully eliminate the peel-off forces and successfully replenish the resin that you cured, and you begin to do it at higher speeds, you run into a third obstacle, which is kind of the thermal build-off, the thermal runaway when you start printing at those speeds. And for that, we had to develop an active cooling system. And when you do all of that, you still need to be able to manage the resin refreshment, and for that we developed an active resin pumping and recirculation system. When you put all of that together with a light engine that can give you a much larger build area in XY, and you add to it the Z stage that is very, very precise and very fast, all that together allowed us to overcome the size limitation, the speed limitation, the uniformity, the edge-to-edge uniformity limitation, the thermal management issues, and the resin variation in viscosities management issues. That's how we can guarantee higher speeds. And I want to emphasize that it's not one speed fits all. With lower viscosity resins, we can easily get to a centimeter in Z per minute. As the viscosity of some resin is higher, the print speed slows down a little bit. In all cases, we are at least between 3 and 10x faster than today's state of the art, and it's a point in time. We hope to be able to do better. The moonshot here is to get to to kind of real-time printing. What I can tell you, Victoria, and to everybody else on the Hangout, is that we learned during COVID that we can successfully do live demos on Zoom for customers and print about 125 parts in 6.5 minutes. And we can do that repeatedly all day long, which means that there is an opportunity here to get closer to real-time printing, which is why we started.
And I guess all of the people who've attended today, if you want to learn more about Nexus 3D, or if you're interested in technology, of course, you can reach out directly to Avi. So my final question is really linked to a point you made earlier in your presentation when you mentioned the sort of changing landscape with publicly traded or more established companies sort of struggling. So my question is, what, in your opinion, should these companies be doing to maybe adapt to the current climate? And sort of linked to that, where do you see the greatest opportunities for growth for AM at the moment?
Excellent question. I would give the more established companies the same advice that I give the early stage companies, and the advice that I take myself. We have built a great industry, and we've created amazing technology and education and awareness. The constraints of the more established companies today is that they have much higher fixed costs, they have more mature technology, and it's much harder to innovate when you have all these investments in decade and a half long technologies, because you're kind of in a box, and every time when you try to innovate, you kind of bounce off the walls of the box because you've invested so much in it. The more established companies will need to find ways to team up with and collaborate with younger companies, leverage their access to market because they have tremendously good distribution and reselling channels, and open those up to new innovators to come in, or they will over time kind of atrophy. We will need to find some opportunities for collaborations and partnerships between companies, which will be pro-competitive because it will be good for the end users, similar to what we just announced yesterday with Henkel, and similar to collaborations that we have with other companies, because no one company can do it alone. Coming out of COVID, there are lots of opportunities because additive manufacturing is going to be on everybody's mind. It's going to be on the mind of countries and hospitals in terms of emergency preparedness. It's going to likely to be part of future emergency response in the form of having more 3D printers in hospitals and in stockpiled for future deployment. It's going to be part of consulting companies and manufacturing companies in terms of how they reimagine their supply chain after being sometimes shut down for 6-7 weeks and not being able to get parts from China and other locations. So there is a real opportunity here to reorganize, to become more agile, to find the collaborations. And in some cases, there may be a case even for a few companies to merge as a result of this. You know, sometimes a massive shock to the system creates more clarity.
Right. Thank you so much, Avi. I think that was a great summary there, and a great note to end on. And if anybody attending or watching this wants to reach out and get more information, you have the contact details on the screen, but we'll also obviously share post-event as well. So thank you again, Avi, for joining us today.
Thank you.